In this problem, you are traveling in a straight line. So again, let's draw a sketch. Sketches always help. And you have a constant acceleration, and that acceleration is given to you, which is 0.5 meter per second squared. So initially, your velocity at this point, and let's call it simply VO, which is state 0 state, is 13 meter per second. And because you have a constant acceleration, after a while you have got to state 1, your new velocity now is 18 meter per second. And you need to determine how much time it takes to get to your new velocity, and also how far you have traveled while doing so. So your initial time is simply 0, and T1 is unknown. That's what you need to find out. Your initial position, it really doesn't matter. You can set it to be 0. And S1 is going to be what you need to find out. The reason why I said this doesn't matter is because it's the difference, delta S, that you're trying to find out, which is S1 minus SO. Therefore, you can set your SO to be an arbitrary number. Your S1 will change accordingly, but delta S is going to be the same, and that's what interests you. That's what you need to find out. So why don't you, since you are allowed to set S0 to be an arbitrary value, why don't you make things easier for you and set SO to be 0? So again, you can apply 3 equations between these two states, 0 and state 1. The 3 equations, once again, are V1 equals to VO plus ACT1. S1 equals to SO plus VOT1 plus 1/2 ACT1 squared. And lastly, V1 squared equals to VO squared plus 2AC S minus SO. S1 minus SO. So again, these are the 3 equations derived from the 3 basic kinematic equations with acceleration being a constant. So again, which one do you choose to solve for T1? So I think to solve for T1, the first equation makes perfect sense. This one right here. Because T1 will be the only unknown in this equation. V1 is given, that's your 18 meter per second. VO is given, that's your 13. AC is given, that's a positive 0.50 times T1. So T1 is the only unknown. From there, you can solve for T1 to be 10 seconds. So that's the answer for the first part. And then for the second part, you need to find out S1. So again, which equation to choose? If you haven't determined T1, then this equation will be the best choice. If you haven't determined T1, you realize that if you use this third equation, you don't need to determine time at all, because it provides you with a direct relation of velocity and displacement. So if we choose equation number 3, V1 is given, that's your 18 squared, equals to VO is given, that's your 13 squared, plus 2 times AC, 0.50, times S1 is what you need to find out. SO is 0. So as you can see, it's the delta S that you need to find out. So in this equation, you only have one unknown, which is your S1. You can easily solve for S1 to be 155 meter. But since in this problem, we have already solved T1 for the first part, So at this point, it actually doesn't matter. You can use the second equation as well. Second equation says that S1 equals to S0, which is 0, plus initial velocity 13 times T1 that has been solved for times 10, plus 1/2 times 0.5 times 10 squared. So if you do that, it will give you the same answer, 155 meter. So once again, if you don't need time at all, I would choose the third equation. But since you have already calculated time from the first equation, then second equation is fine as well. So this problem is not very difficult, but again, it provides you with the practice to evaluate what you have, what you need to find out, and decide which equation is the best to use.